In just 15 years, the cost of sending 1 kilo into orbit on a rocket has plunged from around $50,000 to less than 300. In 2024, for the first time in history, private companies surpassed total government launches with 3 more commercial flights than the 220 state-funded missions. It all points to a space economy growing at a meteoric pace, which is set to be worth at least $1 trillion in the next decade. So, with commercial space travel within reach, and with a rush for resources on the final frontier, what are the potential out-of-this-world industries set to emerge from the galaxies, and how will that impact life on Earth? I'm Divya Gopalan, and you're watching Connected on TaiwanPlus. To understand the potential and the pitfalls of the space economy, we're joined from Aliso Viejo in California by Dr. Bidushi Bhattacharya, a former NASA scientist-turned-astropreneur. She is the founder and CEO of AstroHub. Great to have you on the program. I understand you worked for NASA before starting your venture. Can you tell us a little bit more about AstroHub and why you decided to make the move to, as you call it, an astropreneur?
Thanks for having me. And yeah, I have been passionate about space my entire life, ever since I was a little girl and watched us land on Mars. And after working for NASA for a few years as a scientist on the Hubble Space Telescope, missions to Mars, and a bunch of other projects, I realized that the work that Elon Musk was doing, the commercialization of space and rockets, that was really where things were going to go in the future, because government budgets are fixed and we wanted to do bolder things which required more money. So I started AstroHub when I was in Singapore, initially as a space education company, and we would send student experiments to the International Space Station, which is a satellite that astronauts live on, where they conduct research experiments. And after doing that for a few years, and after the pandemic, I realized that as the global market's growing, there are a lot of other companies that come in and do similar kinds of things in education, just in local languages. So we have now repositioned ourselves as a consultancy. And what we do now is get companies that are space adjacent or early stage space companies who have technology that they want to transfer into space. Right, an example might be a company that does architecture and they want to monitor their buildings from space, but they don't know exactly what kind of cameras they want to use. They don't know exactly how to manage the data. So we consult with them and provide them with a business case and an overall strategy to be able to take their tech and be able to expand into the greater universe, if you will. And it's a very exciting time to be in this sector. I was just in Taipei at the Asia Pacific Space Community Conference, and there was so much going on in Taipei. I was very excited about it, and it's just a really great time to be in the industry. So my whole goal is to get people excited about space and really understand how it's part of their daily lives, right? Like your phone. Your mobile phone definitely is something that connects you with space all the time. But yeah, this stuff is happening. People don't really take it seriously, but if you follow the sector, and you look at what we're actually doing, you'll see that these things are for real. They're not just science fiction anymore.
Indeed, and I do want to get into Taiwan's space ambitions a little bit later in our discussion, but before we go to that, I just want to set the scene here. Now, space exploration and space ventures used to be mostly in the realm of the government, the state-funded, but now it's very much moved into the commercial arena. Can you tell us what it is that allowed that to happen?
It's actually really important that people understand this. The same technology that sits on your mobile phone in your hand is the same technology that has enabled the space sector to go commercial. Costs have dropped. If you think about the computer, the little chip that's in your phone right now, that would have been the size of an entire room a few decades ago, right? So now we have these smaller, lighter computers, and we also have reusability, which is absolutely huge. Elon regularly reuses components of his rockets, and that has dropped the cost of launch into space by a factor of 1,000. And people are getting on board and realizing that they have competencies that can be applied to space that to date they hadn't even thought about. So it's the miniaturization of technology, it's the reusability of space components, and it's just the global contribution from people with a lot of different talent.
And now there are many estimations out there, but in general, I think the general thinking is that by around 2040, the space economy could grow up to between $1 and $2 trillion. Which sectors do you see or do you identify as the ones that would be the fastest growing and the ones that would have the greatest returns in the short term?
Yeah, so that is very short term, right? Especially for technology as complex as this. There are things that are going on right now that I think it will really be monetized. For example, people are using satellite imagery to look at crops. And so if you want to look at a rice field in southern Taiwan, for example, you would want to understand the health of the crops. And this is something that can be done by space by monitoring for a very regular basis. And at this point, people subscribe to get those images, or usually they will also go and get the data analytics from the company, because you may not understand all the squiggles and all that come out in the images, right? So, but somebody would analyze the data and tell you, hey, I think your crop will be ready to be harvested in 3 weeks. So this is essential, especially because we live in an era of climate change. And today's rice fields mature very differently than they did in the old days, right? So the satellite data, which gives a certain cadence of information, is very important. The other really big area is probably something that you take advantage of already, and that is the use of satellite technology for internet. So if you're in an isolated area, these days, even on mountaintops, you can take along a portable Starlink and get yourself internet signal. So I think those are the areas that are monetizing, and they can monetize very quickly. And governments are also doing something really important, and they are now sponsoring different efforts where we have things like the commercial lunar payload services for NASA, where the government wants to hand off some of these things that are done more regularly by bringing in companies and investing in them to the point where they can, sort of be given the resources needed, and then they go and they do these things on a regular basis. So all three of those areas will be monetizable very quickly, I think.
So would this be your SaaS spin, Space as a Service? Do you think that that's going to be like how we use software as a service at the moment? Do you think that's going to be as generally used in the future, given the fact that satellite feeds information from space is so much more accessible?
I think that's absolutely right. Space as a service is an area that's growing very quickly. And in addition to getting these satellite images or the spectra from space, you can also, and the telecommunications, there's some other work that's very interesting. There's a company in Taiwan called Satoro that is actually building satellites, small satellites into which you can put your own cameras, you can put your own sensors. And what they're doing is they're saving you the work of building an entire spacecraft. They're saving you the work of getting the data down to Earth from space, and they're saving you the whole operations aspect. And so it's basically what you might consider a ride share to space, with them managing all the interconnectedness of the electronics for you. You just give them a camera and they send it up for you, and it's much more efficient. And those kinds of services where they allow you to come in with what you have specifically a need for without doing all the extra work, that's really the way things are going.
Now, a topic I'm hearing more and more about is the whole idea of space mining, be it moon mining or asteroid mining. And I understand that's one of your interests too. Could you tell us more about that and why it's being seen as a viable, or is it being seen as a viable part of the space economy?
It's going to be a viable part of the space economy in the coming years. I would say probably within 15 to 20 years, we will be able to bring back material. Now, in terms of financial viability, that's a different story. Because look, we already have brought back material from asteroids, and we know how to dig around on Mars. We know how to get to the moon. All of this just has to be put together in a cost-effective way. And the reason asteroid mining is so important is, as we all know, we are running out of resources here on planet Earth, particularly rare earth minerals, which are critical for microchips, the whole semiconductor industry, for batteries. All of these things are very difficult to mine. There is, in fact, somewhat of a geopolitical issue with monopolies. And the biggest thing that I worry about is the environmental damage we do on Earth by mining. We actually have to use acids to pull these valuable minerals out of rock. Now, when you go into an asteroid, the wonderful thing there is it's made of all the same materials that the Earth is made of, the Earth's crust. right? Because the asteroids are basically a planet that never coalesced. So everything we have here, they have there, but they don't have geology. We have the mantle shifting and the churning of the rocks over billions of years, and asteroids aren't big enough to have gravity to do that. So the material there is very separated. It's already very differentiated and easy to access. The only issue here is we're going to have to figure out how to put all this technology together and go and get the material and bring it back. And we can also go to a practice area on the moon where they have a lot of these tiny, tiny asteroids, the meteorites that are just sitting on the surface that we can get. Yeah.
So, wouldn't it be great if we could just, bypass all the environmental damage and instead go straight onto these asteroids and dig out the materials that we need without having that collateral? But, asteroid mining has gone from science fiction to the possible realms of reality many decades ago. What would you say, and you briefly outlined it, but what would you say is the key point or key challenge that has to be overcome to make it reality and make it something that can actually be used here on Earth?
So yeah, we are moving very quickly. I think at this point, the technology in and of itself is difficult. We have to be able to put all these different systems together, work in basically an almost zero-G environment. And people are working on this very aggressively at this point. The market demand is certainly there. And the reason I am so confident that we will do asteroid mining within the next 15 to 20 years is we now have AI. And using AI, we can do modeling much more quickly. We can do tests in a so-called digital twin environment where people can go in and try different parameters, get guided by the AI to see if a certain design for a certain component would work. And things are going to accelerate very quickly. And so I think the technology development will not be as slow as people predict because we've got this new partner in terms of artificial intelligence.
Right. So I understand that several companies, Astroforge, Origin Space, TransAstra, to name a few, have been attempting or demonstrating missions in the next 2 to 4 years. Which missions do you believe have the highest chance of proving commercial viability and why?
So I think that what these companies are doing is taking an incremental approach, which is really smart. They need to develop propulsion systems. They need to develop launch systems for a microgravity environment where they don't, actually destroy the area that they're launching from. So you also need to understand better where you can actually land, because on the moon, for example, there have been several landings where the spacecraft has toppled over because we don't have a good understanding of the terrain. There's only so much we can learn about asteroids here on Earth using telescopes. There are companies that are launching telescopes into space so they can better characterize the entire surface of an asteroid as it rotates. And once all of these technologies come together, I think we'll be able to identify more clearly which of these companies is going to come out to the forefront. But in the meantime, I think they're doing a great job with all these logistical kinds of technologies that they're developing.
Help me understand what the process will be in asteroid mining. I mean, does all the machinery go up into space and does it get mined in space, or do the materials get brought back here? What would be the most viable process, or what are the processes that are being looked at the moment that could possibly bring faster commercial returns?
I think the biggest market will be in space itself. There are a number of companies that are building space stations right now. These are satellites that go around the Earth where people live and do research. And there's also a huge effort by many different countries to put human habitats on the moon. And so it's much easier to get from an asteroid to what they call the cislunar area in the moon and space stations than it is to come back to Earth. The material that's required, all the equipment, will have to be launched. We also have the advantage of 3D printing. We can start to use material from the moon itself to design some of these components and build them. So I think that it will be really the space-to-space economy, asteroids to space stations, asteroids to the moon, that become the first step. And I think the cost will really come down once we get that first load of equipment up there. That's a huge upfront capital expense, but eventually we'll be able to do this in a more systematic way and deliver these products and services up in space for people who need them.
You know, this is so fascinating. What resources do most companies have their eye on, and what do you have your eye on as far as being able to, you know, quickly start mining and possibly most realistically start bringing back to Earth? Like, what kind of resources? You spoke about rare earths, or is it other kinds of metals? What do you have your eye on?
I think it's going to be water. There's ice on these celestial bodies, and if you just use heat to vaporize it and then collect that vapor, it condenses back into water, and that can be used for everything from drinking for humans in human colonies, or and also used to do all kinds of processes for mining as well. There is another area which I think is kind of fun to think about, and at least in the early days, if you're able to go and get a tiny piece of rock and bring it back, you can sell that as jewelry for a small fortune. I think there's a large market out there of people who will actually want to buy these little pieces of moon chips or asteroid chips in the early days. Once that becomes commonplace, that market will drop out, but the human need for water, from heating up the water on the asteroids to and condensing the vapor, I think that's really where the market's going to be in the longer term.
Let's talk about another sector, the platinum group metals, which on Earth are just concentrated on a few countries, but from what I understand, is more widely available, or there's more of those resources up in space. Now, if, for instance, a 500-meter asteroid gets mined, how much could that yield? And how much would that disrupt what's happening on Earth, the market here on Earth for platinum?
That's a great question. The disruption is something we've seen in history before. If you're familiar with aluminum, it used to be a very precious material, to the point where in the US it was put on top of the Washington Monument as a sign of just how much we valued the country here. But then eventually some people in a lab figured out how to make it just using chemistry. And at this point, it's a material that you will find your food wrapped in, and it's very, very, very cheap. So that market completely changed, and the demand for the product completely went basically and the demand for the product is now very commonplace. Now, in terms of the asteroid, there are market studies out there that will tell you how much an actual asteroid is worth, because they're not all made out of the exact same material, but we know how much they cost per kg, and you can figure out the size of it using telescopes. There's certain asteroids that can yield up to $83 billion worth of product. And the amount of profit that people project based on current market prices is they could make something like 30 billion off of that, just on that one asteroid run, if you will. Now, getting there is very expensive, so you'll want to choose ones that are easier to get to, particularly in the beginning. But the potential is huge, and as you're indicating, the possibility for disruption is absolutely huge, and it's going to happen. It's inevitable. But I am not an economist. This is an area where I think that economists and the governments should come up with regulations to be able to limit the inflow of these materials so we don't collapse the global commodities markets.
Speaking of regulations, do you think we currently have the correct legal framework, or the current space laws are adequate to now include this whole idea of commercializing of space and the competition that will come from that?
I think that the laws that we currently have are outdated and quite limited. These were developed years ago. I mean, there's certain ownership issues which they try to resolve using the model for Antarctica, in that it's all common space, nobody can own it. But people actually in certain countries, Luxembourg and the US specifically, have said they will retain all rights to ownership of whatever they mine. But who is going to enforce these rules, and who's going to actually develop deeper regulations to identify zones of exclusion? Because certainly if you're mining somewhere, you don't want somebody else to come in with their robots and start mining right there. And there has to be some way of defining who owns what, and the way in which profits will be shared. One of my biggest concerns here is that economies that are quite small, that are still developing, will be completely left out of this whole huge profit that we're going to get from asteroids. So there has to be some way to equalize the gains from asteroid mining.
Yeah, and as you mentioned, currently the space race is dominated by a few big countries, which include the US, and China is already investing heavily into asteroid mining R&D. Can you see who, or is there a clear picture of who could be emerging as possibly the leader in asteroid mining or commercializing resources in space?
There's a huge opportunity here to go global, right? China is a single country that's trying to accelerate their development, and other countries are doing the same thing. But I think one of the ways to fully engage and make everybody into a spacefaring nation is to take the countries with smaller economies and have them provide components. So, for instance, Taiwan could get into a partnership with a mining company in Australia and with a rocket company in the U.S. And those companies would provide materials to make semiconductors in Taiwan itself. So this is a great opportunity for everybody to come on board. And it's difficult to say at this point who's going to come out ahead because it's very much an iterative process. Somebody could become an expert in propulsion technology. Somebody else could actually become an expert in solar power or nuclear power that we have on these asteroids. So I see it as a great chance to get this into a whole global framework.
Right, and speaking of Taiwan, and I understand you were here recently, what sense did you get about where Taiwan is? It's now very much in the nascent stage of getting into space, or its space ambitions, but is there much discussion at the moment about asteroid mining or looking into getting its own space resources, given especially the kind of industries Taiwan currently runs on?
Absolutely. There's a huge amount of interest in component manufacturing for space in Taiwan. And I got a very large sense that the techies there are very hungry. There's a lot of business interest, a lot of investment interest in this area. It's growing so quickly. And I have to say the nations that get in there first will do very well, and they will be able to define the direction in which the whole industry goes in the coming years. So my sense is Taiwan is very excited, and the engineers and scientists and business people are fully committed to jumping on board and getting to the point where we are mining asteroids on a regular basis.
Now, while this is such an exciting possibility and has so much potential, refining and processing in microgravity is still largely unproven, especially at scale. Can you tell us about the kind of work that's going into that, and whether you feel like this is something that can be easily overcome, whether it can compare? It's something we can learn here on Earth before we have to send multiple missions into space to perfect the process.
Space is hard. That's just the way it is. But we have a definite advantage with AI these days because we can set up simulations very quickly to try different designs and different components and see what works and what doesn't. And that's accelerating the technology development pretty quickly. The issue here really is that there's so many different subsystems that have to come into play to make this all work together, that it's definitely an incremental approach that we absolutely have to take. But I think that the AI, people are very interested in getting AI to work for space. And one of the areas that I think will really be affected by that is asteroid mining.
Right. Okay. And one of the other topics that many people are talking about right now is the whole idea of, and we spoke about this very briefly, is about commercial space travel. Where are we at if we kind of move away from the mining of resources and going into purely the idea of making space accessible for the wider public or more people out there? Where are we right now with that? And how, I understand there have been some missions where we've seen multimillionaires and billionaires attempt. Where are we at in making it a reality for more people?
I think we're going to be there probably within another 15 years or so. So I did a bit of modeling a few years ago where I looked at the rate at which technology develops. If you look at computers, for instance, their capacity, sort of doubles every 18 months. And I projected that onto the cost of spacecraft travel today. As you said, millionaires and billionaires are the people that go. So that cost will continue to drop and will probably be at the level of, say, $500,000 at 15 years. And if you project further, I think in the coming decades, that cost will be about the same as a first-class airplane ticket going in internationally. So I think it's definitely accessible. And as I told my husband, I'm taking him to space for our 50th wedding anniversary. We have a few years to go, so the price can drop.
Right, and so why would you, as you mentioned there, that you are very interested in going to space, and which is fully understandable given that you are in the industry, but what would you think would be your greatest takeaway from going to space?
I just want to be part of the technology that goes into space. I want to be able to look down on the Earth and see how magnificent it is. And I think that, there's a thing called the overview effect. When people go into space and they look down on our planet, it really permanently changes their perspective and makes them realize how we are living in a very fragile planet and that humanity is all tied together by this singular place where we live. And I just get goosebumps thinking about the opportunity to be able to see that as a whole from in space.
Right, and a lot of the focus, and if we bring it back down to the idea of competing countries and those, who really are looking into commercializing space, or even space exploration, at the moment, a lot of the focus is on the US and China. Can you see any other countries in Asia emerging as giving both those countries a run for their money when it comes to space?
Well, Japan is very active in space, as is Korea, but I think the primary player will be India. You've got a huge population of talented technologists, and India is very good at dropping the cost of spacecraft. For instance, they went to Mars for something like 1/3 the cost of what the Americans had done in the past. So I think that India can definitely give a run for their money to the US. But there again, I really hope to see cooperative partnerships so that people can specialize and get us there even faster.
And finally, if we do send you to space, which planet would you like to go to and why?
Oh, I would go to Jupiter, which is a gaseous planet, so I couldn't really land. But I did my doctorate on Jupiter and their version of the aurora, the northern lights. So I would just love to be there and see it up close.